Hello everyone, it's really good to see you here. So today we are going to solve a GFG problem which is count occurrences of anagram. It's a very important problem with respect to sliding windows. So let's see how we can solve this. So let's suppose we have given this pattern and then this text. So what we have to do is we have to find all the anagram possible. So anagram means, so let's suppose I'm writing this for. So anagram of this would be ORF. So if we can arrange all the elements that are present inside this string in any order, but the number of occurrence of each word would be same, and each letter of this word would be present here. So what I mean is that let's suppose we have this pattern AABA. So the count of A is 3 and the count of B is 1. So anagram of this would be you can say that here in this string you can see that A occurs 3 times and B occurs 1 time. So this is an anagram of P because each element that is present inside P and each element that is present inside T has the same number of count. That's why we called it anagram. Okay, so now let's see how we can solve this problem. So we have given this string T and we have to check how many anagrams are there. So let's see. First one is this AABA. So it has 3A and 1B. If we move this window here, then you can see that here also we have 3A and 1B. If we now move this window here, so we cannot consider it in our answer. That's why, because here we have 2B and 2A, so it cannot be the possible window. This is AABA, so here it also has 3A and 1B, so it can be a possible answer. Now if we look this, then here it's also a possible answer. So we have a total count of 4. So 4 anagram would be our output, or let's suppose answer. So how we are going to solve this problem is that first, let's suppose we have the string, right? So we are going to take 2 pointers. So first one is the I pointer and second one is the J pointer. And let's suppose for the instance both are at this position. So we are going to apply sliding window because you can see that we are sliding the window and then checking if this is a possible answer or not. So the size of the window would be K. So till the point we reach K, we have to we have to increment our J pointer. So once J pointer reach here, we have to check whether this is an anagram of the string P or not. So what we are going to do here is that firstly we are going to map all the elements of this P or the pattern. So you got the count of each element here, right? And then we are going to have a count which is the size of the map. So here you can see the size of the map is 2. That's why we are storing 2 in our count. So how we are going to utilize this count is that let's suppose we are here, we are at this position. So I'm going to use this J property. So let's suppose J is, for instance, is at I. Now what we going to do is we are going to check whether this element is already present inside our map or not. So in this case this element is already present, right? A is there. So we just decrement the count. So now A become 2. Suppose this is A, this is B. So A become 2. Now this J move at this position. So or let me just use this pointer which is going to point. So here J now comes at this position. Now here also A is present inside the map, so we decrement its count and now it become 1. Now we move forward. J is at pointing at B, so we check that B is also present. So here the count of B is 1, so it becomes 0. So once we are hitting 0 for any term, what we are going to do is we are going to decrement this count. So now the count become 1. It's not 2, the count become 1. And once we move forward, we again found a. So we decrement the A count here. So again we got 0. So what we got is that each element is exhausted inside our map, or we can see the count of each element is 0. That means this particular substring of T is an anagram of the string P. So we just decrement the count. So here also A count becomes 0, so we just decremented count. So you can see that now the count becomes 0. That means it should be our answer, right? So once we are done with this, what we are going to do is, now we hit the window size. So here now J is pointing at this position. So what we do, we just take, let's suppose, C equals to 0, which is going to store the answer. So we just increment it and then make it 1. Now the same procedure will repeat for next points. So let's suppose now J is pointing at this position and I is pointing at this position, and we had hit the window size. So what we now do is, we now increment the I pointer and we now increment the J pointer, right? So I come here and J come here. Okay, now in this case you can see that uh, we had done some computation for this A, which we have to exclude because we are not going to include that in our uh, further window, right? So what we have to do is, here each time we are hitting any element which is present inside the map, we are decrementing its count. Now what we do, we just increment the count. So this A element is already present inside the map, so increment its count to 1. Now after incrementing the count, what we have to check, that if this is count is equal to 1, if this is equal to 1, that means we have to again increase the count of this C, so it become 1. And then here you can see that now we have this particular substring, and we have to check whether this is an anagram of the string P or not. So you can see that when we are here at J pointer, you can see that, so now the A count is 1, B count is 0. So after we increment our J, so firstly we have to apply the condition for the I, then we are going to increment J. So once we increment J, we have to check that if that particular element is present inside the map or not. So you can see that this is present inside our map, so we make it 0. And once it becomes 0, we have to make it 0. And again, when the condition reach, now the window size should be maintained, right? So we just check that if this is 0, then we add 1 to our count, so now our count become 2. Okay, in this way each time we move forward and check. So let's suppose now I is pointing at this position and our J is pointing at this position. So I is pointing at B and J is also pointing at B. So this is I and this is J. So here you can see that this B is already present inside our map. Okay, so let me use this one only. So now each of them is 0, right? So what we are going to do is, this is 0 and this is 0. So once we check for this I, so B is present inside the I, so we just increment its count to 1. Now it become 1. And once we are incrementing the count, we check that if it is incremented only once, then we have to increment our C count. So it become 1. Now we check for the jth element. So here you can see that what happens is that when we make this one and when we again come to this J, right? So here you can see that A is, in this case A is 0. So we are at B. Okay. Okay, so before this I, we have to check for this I, right? So here A is already present and we are now going to exclude this. So what we do, we just increment this count 1. And then here also we have to increment the count 1. And after that we are going to do the I plus plus and J plus plus. So once our J reaches here, we have to check whether this element is already present inside the map or not. So you can see that B is present. So we just decrement this count to 0. and once it's hit 0, so what we so here we have to increment this 1, right? So here we got this 1. Now our b value is also not 0. B value is also not 0, so the count should be 2 here, right? And then once we hit 0 here, we have to make this 1. So since we have reached this particular window, and then we have the value 1, so we cannot consider this in our answer. But we have to check that if this b element which we are going to exclude is present inside the map or not. If it is present, then we have to increment its count. Now it again become 1. So this is how we have to iterate throughout the window and check whether it is present or not. So the thing which we have to keep in mind is this: the map element. So each time we are assessing some element at the pointer j, we have to increment the count. Each time we have like if each time we are incrementing the I, before that we have to check whether this element is already present inside the map or not. If it is present, then we have to decrement the count. And the thing which we have to keep in mind is that first the window size, and the second the c. So the count, so count is basically representing the size of the map, and if this count hits 0, then we add or consider it as our answer. So let's look the code. It would be much more clearer. So here what we have done is k is representing the window size, and we have taken a map, and inside the map we had put each element inside it. Now what we do, n is the size of the pattern or the text, and I and j are the two pointer pointing, and then c is going to store the size, c is going to store the answer. So each time we are facing some anagram, or we are encountering some anagram at a window size, we just increment the count of c. Now this count is representing the m size, so it represents how many identical elements are present inside our pattern. Now we just run this while loop till n. So firstly what we are going to check is if the text j element is already present inside our map. So if it is present, then we just decrement its count. And what we check, that if this count becomes 0, that the m of txtj it becomes 0, then we decrement our count. That means that particular element is exhausted. Now if we didn't reach our window size, then we have to increment the j count. Else what we have to do is we have to do this. So firstly, if the count is 0, we have to increment the c count, because that is going to store the answer. Also we have to check one thing, that we are going to exclude the ith term. So we firstly check that if this text I is already present inside the map, then we have to increment the count. And also if we are incrementing the count from 0 to 1, that means we have to also increment the count pointer, right? And after that we have to increment both I and j pointer, and at the end we have to return c. So let's try to submit this out. Okay, so this is the approach to solve the problem, count occurrences of anagram. And if you want to access the code, then you can check the GitHub link given in the description. And before going anywhere, do like, share and subscribe to this channel, and thanks for watching.